Hello dear students, this is my fourth video related to the arches. Today we will see some more problems related to the 3-inch parabolic arch. In the previous video we discussed about the problems related to the 3-inch parabolic arch which consisting of point load. Today we will see 3-inch parabolic arch which consisting of a UDL. Okay, and the question is as follows. A 3-inch parabolic arch of 40 meter and central rise of 8 meter is subjected to a UDL of 20 kilonewton per meter over the left hand side. Calculate reactions, bending moment diagram, normal thrust and radial shear at 10 meter from the left hinge. Okay, here what they are given in the question, there will be a UDL throughout the left hand side of the arch. Okay, left hand side of the arch, that what they are given. So based on the details, so I drawn a figure. See, I drawn a arch, 3-inch arch, hinged at A, B as well as C, and it is of span 40 meter and the central rise is 8 meter, and I considered a UDL of magnitude 20 kilonewton per meter. It is acting throughout its left side. Okay, throughout the left side of the arch. Okay, that what I considered. If it is a hinged support, you will get two reaction, one horizontal, one vertical, even at point A as well as at point B. So first step, as you know very well, so first step is to find out the reaction, second step is to find out the rise and slope equation, third step is to calculate the bending moments, and fourth step is to draw the bending moment diagram. Fifth step is to find out the normal thrust and radial shear. Okay, same procedure we are following now. So first step we have to calculate HA, that intense we can call it as H, that you came to know why. Okay, why we can say that one as H, because here HA as well as HB are same, that's the reason. Okay, so first step is to calculate the reaction. So in order to calculate the reaction, first equilibrium condition I am considering f of x equal to 0. Then we came to know HA and HB are one and the same. So that commonly I consider it as H. Okay. So second equation of equilibrium I applied, summation of f of y equal to 0. Then VA plus VB minus of UDL 20 and its length will be 20 meters because of the arch. So total length of the arch is 40 and half of that one will be 20. So its magnitude is 20 into 20. So if I consider like this, you will get this value. Okay. Similarly, I am considering moment at point A equal to 0. So we have these two forces will become 0. This force will become 0. One force we have, another one we have. Okay. So in order to calculate this one, it tends to rotate anti-clockwise 20 and its length is 20 and it is exactly acting at center. So it will be 20 divided by 2 negative, and VB, this is tends to rotate clockwise. Okay, this tends to rotate clockwise and this tends to rotate anti-clockwise. This is negative and this one is positive. Okay, that's what I have shown here. Okay, from this equation we came to know VB as well as, if you substitute VB value in this equation, then you came to know VA. Okay, after finding that one, then we have to consider moment at the crown equal to 0, either RHS or LHS. Okay, here I solved both the cases because even some of you wants to solve at this portion also I solved, even at this portion also I solved. Anyhow, we know HA and HB are the same. Okay, so in order to calculate bending moment with respect to this point, I am considering right hand side, one force tends to rotate clockwise positive multiplied by its perpendicular distance is 8. VB tends to rotate anti-clockwise and its perpendicular distance here to here is half of this one, it is 20. Okay, that is with respect to C, that what I given here. Okay, RHS. If you want to solve this one in left hand side also I solved here. So VA, its distance will be 20 minus H into 8, but we have UDL here, so it is minus 20 into 20 into 20 by 2, this is a perpendicular distance, equal to 0. Then you came to know H value as 250 kilonewton. Okay, after finding VA, VB, VA, VB, H, then we have to calculate reactions RA, or we can say resultant, for horizontal and vertical component that we will see. Yeah, see, this is a point. We have H as well as VA. We need to find out this resultant RA. For that, this is a formula we are following. So if you substitute H and VA value, you can get resultant at RA, and as well as direction vertical by horizontal. Similar case even for the point B. So you have to find out H as well as, you know H value as well as VB value. You have to calculate the resultant of that one. I consider this one as RB. Okay, and even you can calculate the direction by using the formula. Theta will be equal to tan inverse of vertical by horizontal component. Okay, there ends the reaction portion. Now we have to calculate the rise and slope equation. In the question they are given clearly that it is a parabolic arch. So if it is parabolic arch, we know the equation for y, that is vertical equation, that will be clearly given here. So y will be equal to 4hx divided by L square whole multiplied by L minus x. L is a span, that is 40 meter. H is a rise, it is 8 meter. Substitute all this value, you will get this equation. That will be y will be equal to 0.8x minus 0.02 x square. This is the rise equation. If you differentiate this equation with respect to x, you will get the slope equation. Okay, just I am doing the differentiation here. The rise equation, if you differentiate, that will be equal to dy by dx, that will be equal to tan theta, that is called a slope, that will be equal to 0.8 minus of 0.04 x. Okay, these are the rise and slope equation. After finding rise and slope equation, next step is to calculate the bending moments. For that I am considering the sign convention, that is horizontal force produces always negative bending moment, and vertical force moving upwards produces positive bending moment. Vertical force moving downwards produces negative bending moment. This is a sign convention I am following, and we know that bending moment at the hinges is always equal to 0. So it is a 3-hinged parabolic arch. We have hinges at A, B and C. So bending moment at A, B and C point will be equal to 0. Okay, after knowing that one, next step is to find out the maximum bending moment as well as maximum bending moment at the loaded point as well as maximum bending moment at non-loaded point. For that we have to divide entire arch into 2 portions. Okay, that I will show you now. Yeah, I divided the arch into 2 portions. One it is A to D, another one is B to C. Yeah, you can see from the question. See, this is the arch, this is the loaded point. First I am calculating bending moment at the loaded point. Bending moment at the loaded point. For that, yeah, this is a point D I am considering. So why I am considering point D means that point D is exactly at the center of this UDL, because in a UDL you will get maximum bending moment at the center. So that's the reason. For the year to year it is 20. So D point will be exactly at the center. For 20 means it will be 10 meter. Okay. So D is at a distance of 10 meter horizontally with respect to the left hinge. Okay, that what I given. Now I consider only this figure, that is like this. That will look like this. Okay, yeah, is it clear now? So we have a UDL 20 and it is at a distance of 10 meter, and we don't know what is the vertical distance. I consider this one as YD, and we know horizontal distance is 250 and horizontal thrust H as 250 kilonewton, vertical force VA as 300 kilonewton. We have to calculate bending moment at this point. Horizontal force negative bending moment 250 multiplied by YD, and vertical force moving upwards positive bending moment 300 multiplied by year to year 10 meter. I told you why I considered 10 means UDL at the center it will be a maximum, we will get maximum bending moment. That's the reason I considered 10. Okay, and year to year it is a UDL, it is acting downwards, so it is 20 minus 20 multiplied by year to year distance is 10, okay, and its centroidal distance with respect to D is 10 by 2. That what I can written here, 300 into 10 minus 20 into 10 into 10 by 2 minus 250 into YD. Okay, we don't know YD value. For that we know Rice equation. Under the Rice equation, if you substitute X value as 10 meter, then you came to know YD length, it is 6 meter. That what I given here. Okay, you know that one because we solved even from the previous problem also. We are following the same procedure. Okay, so you substitute this YD value in this equation, you came to know the bending moment at point D. Okay, that what I did it here. So bending moment at point D is 500 kilonewton. That indicates it is a maximum positive bending moment in the portion A to C will be at point D, and it is 500 kilonewton meter. Okay, after finding bending moment at point D, next step is to find out bending moment for the next portion, that is B to C. Okay, in order to calculate bending moment for the next portion, just I considered half of the arch, that is B to C. You can see from this figure. So B to C, B to C, just I considered a point X which is imaginary and it is at a distance of X from the right inch, year to year X, and a vertical distance Y. Okay, that you can see in this figure. Okay, if you find out bending moment at this point, you have only one horizontal force, another one vertical force. Okay, then vertical force moving upwards, positive bending moment, horizontal negative bending. 250 multiplied by YD, 100 multiplied by X. Okay, sorry, 250 multiplied by Y, 100 multiplied by X. That what, not YD. Yeah, it is just Y. Yeah, okay, that what I had drawn here. Now what I did is just I simplified in place of Y the Rice equation, and in place of X I am that the X value we have to calculate, and we are finding maximum bending moment at a point that is at a distance of X and vertical distance of YD. What the condition I am considering is we will get maximum bending moment. If you get a maximum bending moment, if you partially differentiate that maximum bending moment with respect to X, that will be equal to 0. Same principle I am using here. So this is the equation we got for the maximum bending moment. I am differentiating this one partially with respect to X, so that will be equal to 0. Then you can easily find out X value, that is 10 meter. Okay, substitute the 10 meter in the above equation 2. You can easily find out the bending moment. Okay, that is negative indicates it is a negative bending moment. That's it. So you find out positive bending moment, even positive bending moment also you got 500, negative also you got 500 kilonewton meter. Okay, and now we have to draw the bending moment diagram. Yeah, bending moment diagram will looks like this. Positive will be represented above the axis of a arch. This is above, positive indicates it is positive, so above the axis, negative below the axis, and this is point D. You will get the maximum bending moment 500 kilonewton meter, and there is no load here, but X is a point where you will get maximum bending moment, that will be 500 kilonewton. This X distance here to here we identified that one as 10 meter. Okay, if you have doubt, just go back, you came to know that. Okay, and we know at A, B as well as C will be 0, and it is UDL here, so it will be a curve. Okay, here to here there is no load, so it will be inclined straight line. Clear? Okay, after drawing the bending moment diagram, next step is to find out normal thrust and radial shear. So in order to find out normal thrust and radial shear, they are given clearly. You have to find out with respect to left hinge, okay, or left support. Okay, so we know the problem. It looks like this. So left support, from left support to 10 meter, it is this point. Okay, once again I am considering the same figure to find out normal thrust and radial shear. So it looks like this. Okay, here to here distance is 10. We have horizontal force 250, vertical 300 kilonewton, and a UDL 20 of length 10 meter. Okay, yeah. So in the normal thrust we know the formula, radial shear we know the formula. Here unknowns are theta as well as V. Okay, that is shear. Okay, vertical shear. Yeah, in order to calculate that one, we know slope equation, that is tan theta will be equal to 4h by L square whole multiplied by L minus 2x. We know L value it is 40, we know H value it is 8, and what's the unknown here is x. X also we know, they are given clearly in the question that it's from the distance 10 meter from left support, it's from the distance 10 meter from the left support, that what they are given. So I am considering x value as 10. So same 10 I substituted here, so that you will came to know the value of slope. Okay, that is tan theta will be equal to 0.4, then theta will be equal to tan inverse of 0.4. So theta will be equal to 21.80 degrees. Okay, after finding slope, now we have to find out vertical shear. So that is V value. In order to find out vertical shear, just we have to consider what and all vertical forces we will come across in the section 10 meters from the left support. Okay, vertical forces only, not horizontal forces. Force moving upwards is positive, force coming downwards is negative. Okay, here vertical force we have VA moving upwards positive 300, another one vertical force of UDL, it is acting downwards negative, so its magnitude is 20 and here to here distance is 10. Okay, that's it. That's what I considered here. 30 is a vertical force moving upwards, minus 20 into 10, so V value is 100 kilonewton. Now you came to know the unknowns V as well as theta, and you know H value, horizontal thrust it is 250 kilonewton. Substitute all the values in the above mentioned equation here. Okay, substitute all the values in the equation, H250, V100, theta 21.80. Now you can easily find out normal thrust as well as radial shear. Okay, that there ends your problem. If you have any doubt, go through the video once again, you came to know. Thank you. Still we'll see some more problems related to the arches in upcoming videos. Thank you.